Hello, John. I was thinking about how you weren't able to see that graph I generated for your engine, so I thought, well, I'll just shoot a video and show you what I'm actually doing. What we're looking at right now is my laptop computer, and it has this program called Engine Analyzer Pro that I use. It's a $500 computer dyno program. So let's take a look at your engine. This here is your short block, and you can see here we have a bore of 4.6, a stroke of 5.75. It's an 8-cylinder engine. The connecting rod, you can see there, it's 8.85, although that really doesn't make a huge difference. The oil pan, this is the wrong oil pan, let me change that. You're going to have quite a bit of windage in this motor, so we'll put typical windage, because it does make a difference on the power output. But you're going to have a lot of windage, just another way around it with that bigger crank. Okay, the cylinder heads, these are the Big Chief heads. Let me get rid of this. Okay, so we've got a valve diameter of 2.5, and I've set the compression ratio at 10:1, although you're a little bit higher than that. This model, I usually have to take compression out of it to get the power into a more realistic deal. Those are the flow numbers. I don't know that your cylinder heads actually flow that air amount. You can see here at 700 lift we're at about 430. But it is going to be something in that ballpark. It may actually be better because these are very good heads. But it's going to, the heads will flow more air than the engine really needs. And it does make a big difference as to the potential for power with a short cam. Okay, that's the intake manifold. I've gone off a single plane or a single plenum racing EFI system. It doesn't look exactly like that, but it's similar. And the runner length is quite short on it, so I've got it set at 4 inches, which tends to make more top end power and less torque, but torque isn't going to be your problem. It's a bit tricky trying to do this one-handed. The exhaust system, I just put a big Pro Stock exhaust system on. The camshaft is the big deal here. So you can see here I've got a pretty short cam, 238. Now that would be a cam to go 600 RPM in a small block Chevy and have a slightly low-key idle. In your engine, it'll probably have a smooth idle. I've got the lobe separation at close to 110. Let me try if I can get it a little bit closer. This program has a glitch that it doesn't want to give me the actual number I typed in. You can see here it's got a 3-degree retard on it. And I hit straight up. See, it's gone 1.9.7. It's close enough. I'm not going to fuss with it right now. Okay, and that should be pretty much it. And then we're going to calculate performance. We're going to start at 1500 RPM, and 10 increments of 500 RPM should take us to 6000 RPM. And we're running 92 octane gasoline. Okay, I'm looking at the screen and not in the camera, so sometimes it wanders off. So right now we're looking at airspeed in the intake port, and this is measuring pressures. Intake port pressure, exhaust port, that's the exhaust, and this is the intake right along here. So you can see the intake is making vacuum where the exhaust is actually making pressure, and the baro pressure is to do with what's going on outside the motor. Okay, so let's get this out of the way. Okay, so our peak torque in this particular simulation was 905, and the horsepower peak is at 5000 RPM or 45, so it's perfect for where we want it. Up here is the graph. So here, now you can see the graph. I'll pull back a little bit. We're making, there's 2000 RPM, so we're making 800 foot-pounds of torque right off the line. It climbs up to about 900 foot-pounds of torque and then comes back down again. And you see your horsepower comes up to 4500, levels off, and that's where you need to shift anywhere in here. You don't need to take it out here, so that's why we're using the cam, because we don't want to start getting into the higher RPM range because the piston is moving so fast. So that should be a pretty good combination. It may very well in fact make torque up here, but I'm just not sure until we dyno test it. The intake manifold can make a huge difference. So there you go. That's what you can expect from your motor.